Hey, everybody, this is Larry. This is day 10 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today I just kept it used and slept. I wouldn't say I slept a lot, but I just rested a lot. I actually didn't sleep well yesterday. I slept like 3 hours. I woke up, but then I don't know, did nothing, which sometimes is what my body wants. Maybe I need to eat a little bit more. Yeah, marathon's coming soon, so yeah. Weird thing is, I'm not even that tired today. So I don't know. But Thursdays are always my hard days for marathon training. It is basically 12 miles at marathon pace. It's not quite a long run, but it's a punishing one. So I'm always like my body's been holding it, but my mind has just been is so tough, and that's how it is sometimes, right? Like it's not impossible, but it's just that you have to get through it, and hopefully that's all right. And then the marathon's there soon, and then I'll be good. So I was just looking at my water and kind of have to keep on remembering to hydrate, because I don't know if I think in general I've been doing a good job of hydrating, and like in my life I drink a lot of liquids, but I don't know. Still, I've been sweating a lot. Anyway, all right, let's take a look at today's farm. My apologies if today we have 962 maximum width ramp. Don't know what that means. A ramp is an integer array nums. A ramp in an integer array nums is a pair ij where for which, wow, I can't read today. I is less than j and nums of I is less. The width of such a ramp is j minus I. Given an integer array nums, return the maximum width of a ramp in nums. If there are no ramp in nums, return 0. Okay. There are a couple of ideas we can think about, right? The first is obviously the n squared solution or n choose 2 solution, but it's very rarely that easy. And in this case, n is going to be 5 times 10 to the 4th, and that's not going to be good enough. Let's see, and it could be equal to. The idea here that we're trying to think about, right, is they're only I and j, right? So there are only two numbers to think about, and without loss of generality, you can really just focus on one of them, right? Because the other one is just basically equivalent. I mean, like you could, like if you want to do. Like you can do transformation so that like you can do whatever you like, right? Like you can times every number by -1, and then you have this j is less than I, but nums of I is still less than or equal to j or something like that, right? So there are a lot of funky things that you can do. The hard part about this one is that it's because my first thought honestly is that it's going to be greedy, but you can't greedy on the nums of I, right? So basically what I'm going to try to do now is that, okay, let's say we're trying to go for every nums of j, because basically you have to look at every number once anyway. So if you iterate through j, what is the best I for the current j, right? So those are the two ways to really think about it, right? Is that we iterate through j, what is the best I for this j? Or the other way is you iterate through I, what is the best j for this I, right? And like I said, they're pretty much equivalent because you can do some mathematical things to transform them from one to the other. So it's gonna be the same problem for this particular one, right? Another interesting thing to know, which I don't know if it's good yet, is that the range of numbers is small, so maybe you can kind of abuse that, but because one thing that, and I don't think this is this is a right answer, but I don't think this is the right answer, is that based on this, you can actually query, like there's a segment tree solution, right? Because basically you're taking a prefix min with updates, so there's a segment tree solution, which we're not going to do, and we're not going to go through. I don't think that's the solution, and if that's the solution, that's just whack. I don't know, right? But if you want to upsolve it after doing it the normal way. And I think the normal way, whatever it is, I don't know what the normal way is, just to be clear. But whatever the normal way is, it challenges to problem solve a little bit more than just using advanced tools. People confuse sometimes that using advanced tools means you're better problem solving. And no, maybe it's just that, certain people have not invested as much time on it, on learning certain things, but it doesn't mean that it's harder. It's just rarer, right? And you want to challenge yourself to solve harder problems, not rarer problems, I think. We'll talk about that another time, I suppose. But yeah, okay. So no segment tree. So for given J, how can we get the best I? That is, well. So the way that I want to think about it, and again, I don't know how to do it yet, is coming up with a structure to answer queries in, basically, this is how I got the segment tree solution, right? Is that for a num sub j, and we already processed all the previous numbers, we just want to get the first number, or like the earliest number, that is smaller than num sub j, right? Or equal to. I think, okay. So, I think I know the answer, but I want to go over the dot process a little bit first, right? So the reason, yeah. So the thing is that one thing that you try to find is, with these problems is, okay, if we do the naive way, it's going to be n squared, right? Or n choose 2 or whatever. Like, if we're answering the way that I said, which is for each j, we want to get the minimum so that the riff is earliest, right? Then the question is, what are things you can do to eliminate impossible cases, right? And maybe this would come up as an invariant somehow. And what I mean by that is that, okay, let's say we have certain numbers, and I didn't do it this particular problem like in front of y'all, but I think it's also in general, play around with that problems, or play around with some inputs is a great way to kind of gain some intuition. Because I think I kind of paused to think about it, and then that was it, right? The thing is that, okay, let's say we have 6, right? And going from left to right, I'm going to use the V as like a pointer. We have the number 6, right? Well, in the future, and we don't even care about the J yet, but let's say this is I, will we see ourselves using the 6 in the future as a possible I to another number J? I think that's the way we should think about it, right? And the answer is, of course, because we only have one number at this point, right? We don't have any of the other numbers yet. And then, okay, and then the second number is 0. Can 0 be a possible answer? The answer is yes, right? Because, so you have 2 numbers so far, you have 6, 0, and there are really only 3 possible, ignoring the Leetcode signs for now, just because it's just a little bit easier to say. Actually, let me bring up my... I feel like in the past I do ASCII art. People say it's not clear, which is maybe true. I don't debate that much. I don't know. Ooh. But I'm going to bring my drawing pad is what I'm doing. Right? Okay, so we have... we don't really even care about all the numbers yet, right? So let's say we only process 6 and 0, right? Well, between 6 and 0, there are only 3 classes of numbers, right? Ignoring Leetcode signs for now, because... I don't know, just make it easier to say, right? So you have 0, 6, and basically all the numbers, and I know that for this problem there are no negative numbers, but we can just pretend that's the case anyway, whatever. Right, so we have 3 ranges of number, right? Which is numbers that are, so for some x, where x is less than 0, right? Well, if x is less than 0, then I guess the answer is actually there's no answer, because it is less than 0, right? So you have this range after it. And then you have another range, which is that 0, 6, right? So between 0 and 6, right? So that means that, for example, we have a number if the next number, or even in the future, it doesn't matter when it comes, if you have a number that is 3, well, 3 is between 6 and 0, and what's the answer for 3, right? Well, 3 would actually like 0 as a possible answer, right? Because 0 can be a possible answer for a future 3. And then you have the other thing, which is that x is greater than 6, right? If x is greater than 6, then oh wait, did I mess this up? I guess I messed it up, but this is why it is no, I was right. No, I messed up the messing up, so I was right. But yeah, 6 could be the answer for x is greater than 6. For example, if the number is 8. If the number is 8 and your array will look like 6, actually I think the next number is actually 8, but 608, because both these numbers are less than 8, you actually want the one that's earlier on, right? You want the one that's earlier on, therefore you want to keep the 6. And what I did here is to show that, well, the answer can be 6 or 0, right? That's basically it. I know it might not make sense yet, but we'll keep going, right? And maybe it'll make more sense later. Okay, so we know that in the future number, we need both 0 and 6 to be considered because they both could be possible answers, right? Okay, so what's the next number? The next number in the input is going to be 8, actually. So then we do 8, we look at these and we go, okay, 6 is the right answer for 8, we update a best or something, right? But then now it gets interesting. The question is, can 8 ever be the answer? The answer is no, actually, right? Because, okay, let's say you have, let's write out the range. Actually, I'll write it out horizontally this time. 0, 6, and 8, right? So there are 4 ranges in between them, right? It could be x is less than 0. If that's the case, then like if this is a -1, then there's no answer for that one. But if x is between 0 and 6, so x is greater than 0 or 6, so let's say the answer is 4, right? Or the next number is 4, then 0 is actually the best match for it. So 0 is definitely a possible answer. Let's say the next number is 7, right? 6, x, 8, right? Less than 8. So then let's say the number is 7. Well, the number is 7, then the best answer is actually 6, right? Because it is the leftmost, it is bigger, so forth, right? And then the last range is x is greater than 8. If x is greater than 8, let's say we have 10, right? Then what happens? Well, the answer is still 6, right? So that means that, what does that mean? That means that the 8 is never a possible answer, right? And that's really it, right? And that's basically it. So then now, in terms of possible answers, you want to keep 6, 0, and that's it, right? As possible answers for look in the future. Okay, right? And we'll go over the other parts in a second, but let's see. Okay, I know that there's no negative numbers, but it doesn't make sense if we don't have negative numbers for me to explain. So I'm going to do a negative number next, right? Okay, so then now, for the purpose now though, because 8 cannot be a possible answer, we'll just say 8 doesn't exist, right? But let's say the next number then now is -5. Ooh, let me change back the color real quick. -5, right? Then what happens? Well, again, we draw the ranges. I draw it horizontally, sorry. -5, we have 0 and 6. So if x is less than -5, again, there's no answers. One pass. And the reason why I always pick up random numbers is because, or like even put in a placeholder number, is because that lets me visualize much clearer, right? Okay, if the next number is 10, well, then there are no answers. You go all the way to the right or to the left side, and there are no possible answers. If the next number is between -5 and 0, let's say -2, well, then the answer is -5. So -5 is a possible answer. So we do want to keep it, right? We could, I mean, for the purpose, we can go over the 0 and 6 again, but you can also say that we actually did this we already did this calculation earlier, right? We know that we want the 0, and we know that we want the 6 because 0 0 is less than x is less than 6, so x is between 0 and 6. For example, 4, which we already did, the answer is going to be 0, right? And then finally, if x is greater than 6, again, like if we have 10, then the answer for 10 is going to be 6, right? So that in this case, now every number we want to keep every number. Or, well, we want to keep -5 anyway, right? And that's really the idea that you can see from this pattern, right? Okay. And once you kind of, and I'm not going to, if you don't see the pattern yet, maybe pause, rewind, do a few more numbers in every range and kind of play with your numbers, right? Like try it for number 4 next, and then see what happens and what you do with the array, right? And feel free to pause because I'm going to go right ahead. And okay. So then now, after you unpause, hopefully, or maybe you just, want to kind of keep going. After you unpause, then you realize that, okay, well, the only thing, so going from left to right, the thing is that it ends up that you only add number, or a number is only possible if it is smaller than the last number, right? Which is another way of saying it's smaller than all the smaller number. And also another thing is that unlike maybe some monotonic queues or something like, or monotonic stack or whatever, you actually never pop any of these because they always remain possible forever, pretty much, right? So, but basically now you see that you have 6, 0, -5, and it gets smaller every time, right? Whatever, ... right? And now that you can see that this is monotonically decreasing, or actually strictly decreasing, I think, because I know that we skipped decodes, but then now you can think about it, right? Well, if you have a -5, well, this -5 is never going to beat this -5 for the future answers because you can always go further to the left by doing the previous. So you never have duplicates, and therefore this is going to be strictly decreasing, right? Okay. Now that you have this, I think one thing that you might have thought that I skipped, which is true a little bit, is, well, I said, okay, well, let's say you have, 12. How do I get the number that it matches up, right? And yeah, you could naively, if you naively do one at a time, like if you have, clicked off screen by accident. If you add in the number, say 12, you can naively check, okay, is 12 greater than -10, -8, right? But in this case, if you do it this way, it is possible to construct an n-square case, right? And there's a very straightforward way to do it. I'll pause for 2 seconds while I take a sip, and you could see if you could come up with the worst case, or how to construct the worst case. Right? You could construct the worst case. But again, one thing now that we can come up with this problem is that this is strictly decreasing. And because this is strictly decreasing, what does that mean? That means that this is binary searchable, right? Because now you can just do a binary search. In this case, it's a little bit annoying binary search because it's decreasing and all these things, but yeah, but I think the idea should be pretty straightforward on how to binary search, right? You just try to get the first number that is smaller than this number, right? The number that you're processing next. And that's pretty much it, right? So, okay. Hopefully this is a... let me take a break. Alright, hopefully this gives you a good enough idea to at least implement if you just watch this entire time. And we'll do it live, right, as usual. And try to do it together, as as people do. All right. Yeah. So then now maybe we have another. We have best is equal to 0. Are there always a with? Oh, there's no ramp. Return 0. Okay, so then that's good too. So then now we have for x in nums, right? If and there are a couple of ways you can handle the empty case. You can also just do like infinity or something, and then just start it off at infinity. So then now if actually you don't want to insert it yet, so I'll put it at the end, which is that if the last element is greater than x, then we append x, which is what we talked about, right? Technically you want to insert it if it is the smallest element in the array, but you know the smallest element in the array is already at the end, right? So yeah, but then now we want to binary search on array to get the previous index. Actually, maybe I lied a little bit. Well, I didn't lie a little bit, but I think we need to keep track of the index, right? So this is like -1 or something maybe, and we append x and index. That way, this is so that you could use the current index and then the previous index to get the width, right? Because that's what this problem's looking for. Okay, for this one, I guess we can just write it out. There are a couple of ways you can write this, honestly, but I'll just write it out, right? Right is equal to length of array, right? -1, because I like mine inclusive. So then now if the middle of the array, if the first number, because the second number is the index, if that number is greater than x, then we want to try the smaller half of the array, right? So that means that right is equal to mid. What happened to the Leetcode again? I'm so bad at everything. If it's equal, well, if it's equal, it could match. If it's equal, it's a possible answer. So that means that we also want, yeah, right? So if it's equal, it's possible answer. And here we said right to mid because we wanted to have inclusive range. Otherwise, it's too big. Wait, did I do this wrong? Yeah, I did this wrong. I meant if x is greater than or equal to, then now you want to try an earlier index to see if it's a smaller number. Ooh, okay, yeah. Very easy to get wrong. You have to think about it. Well, I have to anyway. And then when it's equal, when it's done, then left is equal to right. Right, and that's the answer. But you have to make sure that if array of left of 0 is actually less than x, if that's the case, then we're Gucci. Then a left of 1 is the previous index, and index is the current index, and the width is just index minus this, and then we just compare it to best, and we are good, I think. I mean, a lot of possible places for me to make a mistake on the thing. So oh yeah, this has to be 0 now. A lot of possible ways for me to have an off by 1, honestly. So I'm not 100% confident. I'll say like 85%, and I'm just being lazy. I could make it 100%, I suppose. I mean, there are a lot of obvious test cases, but okay, good. Yeah, I mean, I think you can. What I would also maybe consider doing is reverse, like do a negative times everything by -1 and then do a regular binary search. Is probably how I did it last time, if I have to ask, because usually that's how I would do it. Oh no, how did I do this last time? This is some craziness. Huh. I don't know how this works. Why is the bisect right good enough? Isn't there a way? Oh! I did an append left, so you could do a binary search. But this is awkward. I think past Larry is wrong, though the code is faster. Because I think a deck does not give you random access, right? So this binary, that's what I thought about it slightly for a second. But I think a queue doesn't give you random access. So this bisect right is actually like very expensive, right? Let me see. Random access Python. Let me Google this. Oh. Huh. So I'm Googling right now and I'm reading Stack Overflow. You can't really see me the way, but it's fine. So it's like, apparently deck is implemented. It's not, I don't think it's quite a skip list, but a skip list-y idea in blocks of like blocks. Okay, well, so it's a fast linked list, so I guess that's how it kind of worked, but it's still not all of one, right? So that's why this is actually the wrong code, because deck does not, it doesn't make sense for it to be randomly accessed. If you can, you know, like that's not the point of a deck. But okay. Yeah, I mean, but this time we actually did it right. I think the way that you would do it if you wanted to use binary search is by doing like negative things, so that now you have a increasing one, then you could do binary search and then rewording it. But you get like really messy with like equals and stuff like this. I always do get off by ones and stuff like that. I'm just really bad at things. But yeah. Anyway, that's all I have with this one done. This is actually I must have lied last time, but this has the actual complexity. This is, you know, O of n iterations and O of log n each. So n log n and O of n space due to this, appending all the time, but pretty straightforward otherwise. But yeah, that's all I have for this one. That's all I have for tonight. Excuse me. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.